All right. Sketch the angle, determine an XY pair, right? The X and Y position, Cartesian coordinates, and determine beta. And the first one, theta, is 145 degrees. So I'm visual, so I start with a sketch. Which quadrant will this be in? Well, the initial arm's on the positive x-axis. The terminal arm, no, it's more than 90, so it's not in the first quadrant. It's less than 180, so it is in the second quadrant, just like that, perhaps. And there you go. I sketched the angle, and I can label it 145 degrees. So we determine the angle. Beta, I guess I can do that. Beta is to the nearest x-axis, not the nearest axis in general, the x-axis, not the nearest positive axis, not the nearest positive x-axis, the nearest x-axis, so right here. And it's always an acute angle, 0 to 90. So to get beta is 180 minus 145, which is 35 degrees. So our related acute angle, beta, is 35 degrees, so we did that. Now to get x and y, we have a problem. We know the direction. We don't know how far. We don't have a radius. Okay, I'm going to make a generalization here, so pay attention. If radius isn't stated, assume r is equal to 1, the unit circle. So unless radius is stated, you are to assume that the radius that you're going to use is 1. So we're going to use r as 1. So we need the xy pair for this. Well, if you memorize those formulas from the last note, or at least recall them, we have xy is equal to r cos theta, r sine theta. 145 and 35 degrees is not special, so it is 1 times the cosine of 145. You can use the obtuse angle, you can use an angle bigger than 180, it'll still work, and 1 times the sine of 145. And we get the coordinates for this point of interest. Negative 0.819 and positive 0.574. All right. So go ahead and try the next one. This time I'm going to give you an r equals 2. And for the coordinates, I want you to be exact. That's code for there's probably a special triangle. Don't use decimals. Doesn't mean you can't use your calculator, but your final answer can't be decimal. It has to be exact. So start off with what you can do. Sketch, do beta, and then work on x and y. Pause the video and begin it again once you're ready. Okay, so we start with a sketch. Which quadrant are we in? Not the first, not the second. We're in the third quadrant. (225 degrees). That's theta. Right? Initial arm, terminal arm. What's beta? Well, beta will be 225. I think we already did this one actually. 45 degrees right there. Okay, we just need x and y. It's connected to cos and tan, cos and sine of 45 degrees. What is the cos of 45 degrees? It's 1 over root 2, or root 2 over 2. And that's actually equal to the sine of 45 degrees as well, right? So when we do the xy pair, and we're going to do 2 cos of 225, and 2 times the sine of 225. First of all, the sine of 225 and the cosine of 225 should be really closely related to the cosine and sine of 45. Try it in your calculator. What do you notice? It's exactly the same except for the sines. So the cosine, remember the cast rule too, right? Cast. The cosine is going to be negative here, but it's going to be negative root 2 over 2. So it's 2 times the cosine of 225, so negative root 2 over 2. And 2 times the sine of 225, which is also negative root 2 over 2. So what do you get? Negative root 2, negative root 2 for the y value. And that's it. Okay, when you're ready, you can go on. Find r, theta, and beta for this. Okay, now it doesn't say to do it, but I always sketch. So it's 4 and negative 2. 4 and negative 2 is point P. 4 and negative 2. There's the angle I need. I need to find that angle. Okay, that's theta. Beta is going to be here. I know that this is negative 2, so this will be down 2. This will be over 4. Okay, none of those things I'd had to do in terms of a sketch, but that really tells me what I need to go about. So r is equal to the square root of x squared plus y squared. So r will be the square root of 4 squared plus negative 2 squared. That's 16 plus 4, so that's the square root of 20. And that reduces, well, 20 is 4 times 5. Square root of 4 is 2, so 2 root 5. Okay, so r is 2 root 5. That's one thing I was supposed to get. Theta, well, I'm actually going to start with beta. And I often, at least for the first couple of times, I'm going to go ahead and do this. And I totally flipped around that triangle just to give you an idea of how to approach this, right? That's what beta is. So I'm just going to get beta first. Tan of beta is y over x, 2 over 4. But notice I didn't bother with the negative 2, just treating it like a triangle. And when I do that, I get a beta of 26.6 degrees. So 26.6 degrees. And now the only thing left to get is theta. Well, it's a simple calculation. I'm not quite 360 degrees around. I am 26.6 degrees short of going all the way around. So that's 333.4 degrees. And that's the last thing I was supposed to get. Okay, so sketch, find r, find beta, and then theta. Get that down, go over it again, and then try the next one. Pause the video, start when you're ready to take it up. Okay then, you don't need to sketch, just I encourage it because that way you're not just counting on memorizing. So negative 3 and down 5, so negative 3 and negative 5. I'm definitely in the third quadrant, so I know the relative size of the angle. There's beta, there's theta, and there's r. R is the root of negative 3 squared plus negative 5 squared. That's simply the root of 9 plus 25, or 34. I can't reduce, so I can just leave it like that. Tan beta, and again, I'd be really careful. Beta's here, and it's 5 and 3, so it is 5 over 3. I get a beta of 59 degrees. And this time to get theta, I'm not going to subtract beta from 360. Beta is 59 degrees right there. So I have to do 180 plus 59 degrees, 239 degrees. Okay, and those are the three things I was to get. All right, one more example left. This is solving trig equations, the basics, and we really dig into the cast rule with that. So when you're ready, turn to that. All right, determine x and y, and beta and theta. Okay. Now, we don't know theta. We're not given theta. We're having to find theta. What we're given is the trig ratio. It's 0.5. Go ahead, use your calculator. It's a special. What does your calculator say that is? Theta is 30 degrees. Yep, that's right. I'm just going to sketch that quickly. There, it's 30 degrees, just like that. That's all great. But how do you know that's the only angle? Well, usually they say theta has to be a principal angle. Okay, so that means 0 to 360. Is that my only option? Well, remember the cast rule. Cosine's positive in the fourth quadrant. All three trig ratios are positive in the first quadrant. Sine is positive in the second quadrant, and tan is positive in the third quadrant. Sine theta is positive 0.5, and my calculator gave me 30 degrees. That's in the first quadrant. But sine is also positive in the second quadrant. Well, what angle in the second quadrant will I get 0.5 when I take the angle? Well, it has to do with beta. Beta is 30 degrees. If this is 30 degrees, what would theta be in this case? So if I put a beta of 30 degrees in the second quadrant, what would this theta be? Well, 180 minus 30, which is 150. So try it on your calculator. Take the sine of 30 and take the sine of 150. Do you get the same answer, positive 0.5? So we have an answer in the first quadrant and an answer in the second quadrant. Which one's right? Well, they both are. The sine of both those angles is positive 0.5. So remember that, I've done beta. I've actually given a theta, two of them. I need the x and y pair. So remember, x and y pairs are r cos theta and r sine theta. Oh, but these are specials, 30s, right? So, what is r? Well, it's not given. What do we assume? Assume r is equal to 1. And let's go. So it'll be 1 times the cos of 30, 1 times the sine of 30. And so I have in the first quadrant, the coordinates are √3/2 and 0.5, or 1/2. Okay. Go ahead and do the same thing for the second quadrant. Well, what changes sign? Well, the x changes sign. The cos of 150 is not the same as the cos of 130, negative √3/2. But the sine of 150 is the same, so it's 0.5. So there's my two possible x values. One for the first quadrant right there, and one for the second quadrant right there. Okay, try this one. Let's do r is equal to 2. Okay, cos is positive in which quadrant? It's positive in the first quadrant, and it's positive in the fourth quadrant. Let your calculator do the work for you. Find the angle in the first quadrant. If you have a positive trig ratio, the calculator will always give you the first quadrant. So use your calculator. Inverse cos of 0.8. You should get a theta is equal to 36.9. Okay. I'd like you to find the position in the fourth quadrant that matches with that. So 36.9, that's the first quadrant. Of course, the cast rule says the cosine of an angle is also positive in the fourth quadrant, the beta will be the same. The other angle we need is this one right here. So to get that, it's 360 minus 36.9, which is 323.1 degrees. Go ahead and get the coordinates. Right, it's r cos theta, r sine theta. Use r is equal to 2. So 2 cos of 36.9. Of course, that's 0.8. And sine of 36.9. And we should get 1.6, right? 2 times 0.8. And 2 times 0.6, so 1.2. For this here, I don't bother redoing the work. The x is still going to be positive. The y has to be negative. Try it out. 2 times the cos of 323.1 and 2 times the sine of 323.1. You should get those two coordinates. Okay. Try this one. Let your calculator do some work for you. Start sketching. Think about which quadrants the tan is negative in. When you're ready, begin. Now, depending on your calculator, you probably get an angle that says negative 45. So which quadrant is a negative angle in? Well, it depends on the size. But negative 45 is this right here. Now, we want angles. This is negative 45, so that means beta is 45. But we want the positive angle, the principal angle, from 0 to 360. So we want this angle right here. What is that? So we don't want that. What we want is 360 minus the 45, which is 315 degrees. That's the fourth quadrant. Where else is cosine negative? Well, cosine, cast rule, right? Cosine's positive in the fourth quadrant. They're all positive. Do we want positive? No, we want negative. So they're all positive in the first quadrant. Sine is positive in the second, and tan is positive in the third. Tan is positive in the first and the third, which we want a negative tan. We already have the fourth quadrant, 315 degrees. So which other quadrant is tan negative in? Not the first or the third, but the second. So let's think about that for a second. Beta is 45 degrees. What's this angle? Well, 180 minus 45, 135 degrees. Go ahead and get the coordinates. Special, so exact values, please. It's related to 45. So I'm going to do the second quadrant first. Oh, what R value? Well, nothing's given, so we assume R is equal to 1, right? Okay. So we do 1 times the cos of 135. That's special, and it's going to be negative 1 sine of 135. Sine is positive in that quadrant, so this is root 2 over 2. This will be negative root 2 over 2. Okay. What will it be in the fourth quadrant? Well, x is positive, but y is negative, right? The coordinates are the same absolute value. The x and y have to be the same. Remember, it's negative 1. The signs have to be different. That's it. That's the end of the examples.